Good day, viewers. I saw this very interesting maths somewhere in university. But let's try to solve a question like this. If y is equal to sine raised to power x, find the y dx. If a question like this is given for you to solve, if I see anything like power, I will apply log to both sides. The reason I will do that is to be able to bring the power to the left hand side. If I introduce natural log to both sides, this is what I mean. Solution. I will apply natural log to both sides. This is my natural log to both sides. I apply it to here. Then I will also apply it to this side. That is step 1. Now, the reason why I introduce this log is to bring the power to the left hand side. Because there is a law in log that says if log MP, if we have something like this, it is equal to P log M. So the reason why I introduce the log is to bring the power down here due to the law that is here. So this is equal to x, this into sine x. Have you seen now? I have been able to bring the power down here because that is the law of log. And the next thing we need to do is to differentiate in respect to x. Differentiate the both sides in respect to x. So this is it. I will differentiate this. This is my y with respect to x, and I'll also differentiate this with respect to x. So now I'm trying to differentiate this and this with respect to x. Now look at this now. We don't have x here. Have you seen? But we have x at the left hand side. Now, when we differentiate this one, because there is no x, it will be 1 all over y. If here was z, the derivative of this will be 1 all over z. If here was p, it will be 1 all over p dx. So since this is y, so that will be 1 all over y dy dx. That is how to differentiate a log function. Let's move to the left hand side. If I want to differentiate this now, let's look at something. I can use a lot of ways, so many ways to solve this. I can use product rule to differentiate this, but I just want to show you the shortcut. We are going to differentiate this in respect to x. There is x here and there is x here. Derivative of x is 1. Derivative of x is 1. So now, if I want to differentiate this now in respect to x, here becomes 1. So what will remain here is 1 times log of this. So 1 times log of this remain the natural log of sine x. That is the derivative of this. Because in respect to x, whereas this one there was nothing like x. So since we are looking for the y dx, the short form is to multiply both sides with y, so that we are going to have our dy dx standing alone. I will multiply both sides with y. Have you seen? I have been able to multiply both sides with y. Now, so that this and this truncate, and we have dy dx to equal to y, this into sine x. Oh, but we cannot stop here. We cannot stop here. We are going to change this sign, this y, to the equation given. So dy dx is equal to, my y was what in the equation? This was my y. Raised to power x. I have changed my y to this. So this is the answer to the given problem above. Now, for us to know the shortcut, if a question is given, remember that in this form, remember that this question will also appear in the answer. The same question given will also appear in the answer. Then we apply the natural log to this. Okay, let's try something like this. I'll come back and solve. If y is equal to x raised to the power x, find the y, the x. As I said earlier, the answer will be, look at it here, the answer will be using the same formats. The answer will just be the y, the x without solving. The y, the x will be equal to, we repeat the equation again, x raised to the power x. Then the natural log of only x, you will not repeat this again. So that is the answer to this one question given. To this one question. That is the same way now. So, but whereas this one can also be written like this. It's still the same thing. It's still the same thing. So if any question is given, for you to go along protocol, just repeat this, then apply log. Forget the power. That is the answer. So do way to drop any question in the comment section. I'll come and pick any question, then we are going to treat in our next class. Thank you. Bye bye.